Welcome all of you. In this video lecture, you are going to learn about multi-level inverter. What is inverter? Inverter means it will going to convert DC to AC. It is a single phase inverter, three phase inverter, you were seen three phase inverter, 180-degree mode, 120-degree mode. What is the drawback of the single phase and the three phase inverter means? There is a two major drawback, that is high voltage stress. High voltage stress on the switches it will going to produce. Another one is a high total harmonic distortion. These two is a major limitation or drawback of that is single phase as well as three phase inverter. How to overcome this limitation means high voltage stress you will going to eliminate it with the help of the soft switching circuit, or you can call it as a snubber circuit, like you will go to di by dt and dv by dt. In SCR you have studied the same type. Here soft switching circuit, or another name it is called resonant converter. It is a method used to you will going to reduce the high voltage stress. Then total harmonics distortion, harmonics. Okay, it is a unnecessary disturbances. Okay, it will going to malfunction. It will going to start to work on the circuits. So that one you will going to eliminate it. So odd number of harmonics, even number of the harmonics, like it will going to classify. So proper filter arrangement. Another one is a multi-level inverter technique. When you have go this elimination, it will going to eliminate the harmonics. And the major purpose is a multi-level inverter is a high power up type of the application, high power high voltage type of application. And the second point you can say about pure sinusoidal waveform. The waveform is a pure sinusoidal waveform. Then it will going to automatically the harmonics level is reduced if we based on the increased number of the levels based. Okay, yeah, we're going to further we're going to discuss. Okay, this is a multi-level inverter classification. It will going to majorly classify on the three type: flying capacitor. Then second one is a diode clamped method, cascade method. Like it will going to classify on the three major type of the multi-level inverter. Out of three, the flying capacitor and the diode clamp multi-level inverter also the same drawback of the high voltage stress it will going to produce. Then that type of stress you will going to eliminate it with the help of the resonance circuit, or it is a soft switching circuit you will going to eliminate it. Then cascade multi-level inverter. Cascade is nothing but it is a series connection. What is inverter? DC to AC, single phase inverter is there. Then three single phase inverter you can connect it in seriously, you can connect it. That is called a cascade. We're going to see about the circuit diagram in forthcoming slides. And then if I have three, for example, three single phase inverter will going to connect it in seriously. One single phase inverter, four switches are used. So three inverter means so 4 into 3. Okay, 12 switches. So switches level is it will going to increase. So number of switches is increase automatically. The switches power driver circuit to go into increase. So about that one. So this is about that is their drawback of the cascade multi-level inverter. Further people is what is the input? The input is a DC source. DC source is they will going to increase that one boost converter. They will going to use. The research is going on about the multi-level inverter. Okay, in that multi-level inverter we're going to compare with that single level inverters. Single level means single phase systems. We're going to comparisons, we're going to do the comparison. What is the difference between the multi-level inverter? Why do we go for that multi-level inverter? It is high power and then medium type of the voltage application you will going to use. And what about the frequency of that one? Here is a high switching high frequency inverter it is used. So high frequency inverter it will going to be applicable, but a single phase inverter high frequencies it is not applicable. Okay, it is applicable on the low frequency. If you're going to increase the frequency, what will happen? The losses value is also it will going to increase. That is a drawback about that a single phase inverter. Okay, yeah, the increasing the frequency. So here a multi-level inverter switching frequency increases. So due to the increase the switching frequency, what will happen? The compact size, compactness, reduce the cost. So that is advantage it is coming. Okay, another one is it will going to come as a pure sinusoidal. You know that one single phase inverter, it is coming on that pulsating DC type of that waveform it is coming. Okay, And then where we are using the single phase inverter means you will going to use for that medium and low power application you will going to use, and it is a simple circuit and low frequency inverter. It is a low frequency inverter and then a simple circuit. Okay, best efficiency and robustness. This is about the single phase inverter merits, but it is applicable for that low frequency. If you want to if low frequency means automatically the compactness is it is not possible. So do you know the transformer also nowadays it is available. You have the possibilities to look on that one in a power electronics board. It is a name, it is called as a high frequency transformer. So the switching frequency of the transformer, okay, it is a high frequency. The frequency level of the transformer is high. So why there if a high frequency transformer is used in the power electronics board means the size, okay, size of the circuit it will go into size, and then component level it will go to reduce its compactness purpose. Okay, then coming to that one, choose the best applications. So multi-level inverter, it is high power application. So standalone renewable energy system type of application you will going to use for the multi-level inverter. So it's a good reliability and the surge power capacity and efficiency about the multi-level inverter. And then a single phase inverter means low frequency application, it is suitable. And then it's off bridge inverter and a full bridge inverter. Okay, if the source side, okay, in the source side if they are using the capacitor is used, a off bridge inverter, there are two capacitor they will going to use it, or two switches they will going to use, on that one two switches and the capacitor is used to they will going to divide it. So what will happen, the source it will going to divide it, the source value it will going to divide into the plus VDC minus VDC. I mean, yeah, so you will going to draw the circuits. It's a VDC value. In the VDC across there you will going to use for the two capacitor means what will happen, the total VDC it will going to divide it into the two. So off it will going to divide it. So off it will going to divide it. So VDC by 2, VDC by 2, like it will going to divide it the values. The drawback is what about it's a low frequency simple, it is a good about that one, low frequency only applicable. High frequency it's not possible. When you will going to increase the frequency means switching losses also increases. You have look about that one, high harmonics distortion THD level is increased. Okay, normally the THD level as well as that one distortion THD level. Another one is a dV by dt. Switching stress it will going to produce. So this is a major drawback about that single phase inverter. Okay, that's why we are move for that multi-level inverter. The why do we move for that multi-level inverter means that is a major purpose. So three-phase inverter, when you have a look at previously we were discussed about the three-phase inverter. Okay, DC source and then it is three phases. Okay, single phase means only two leg, three bases mean three leg is used. So here is our A B C, like in the center point is brought out. So the same concept is applicable for that multi-level also. Okay, here is this a waveform. What is a waveform for that one? This is about that it is a unipolar type of the waveform. Actually PWM technique we were discussed. In the PWM technique it's a unipolar and bipolar available. So waveform is this is yeah, this is about that bipolar waveform. Okay, like it will going to repeat it about the waveform, and this is about that unipolar type of the waveforms. Okay, you okay, a few more differentiation. Okay, basic depth we're going to see. Conventional inverter like single phase, three phase inverter and a multi-level inverter. Why do we go for that multi-level inverter? These all are the advantages. So these all are the advantages. Six advantages there. Only one disadvantage is there. So the complex the circuit. The circuit is complex. Okay, this is a conventional inverter is a simple circuit. Okay, coming to that one, it is a low harmonics, it is a high harmonics, it is a switching losses is a very less about multi-level inverter. Conventional switching losses high, and then it is applicable for high power application, but it is applicable for low power applications. Okay, another one is higher voltage level also you will going to decided, but higher level of voltage it is not decided, and dV by dt stress. Okay, switching stress it is produced. It is very less about the switching stress, but here is a high switching stresses. Okay, lower switching frequency can be used both. Okay, lower as well as higher switching frequency you will going to develop. Okay, hence the reduction in that switching losses. So you will going to use for that more number of switches and the switching okay, lower switching frequency of that each device you will going to use. But what about here higher switching loss switching frequency? If you are using for that higher switching frequency, mean the switching losses is high. So this is about that one is a difference between the conventional inverter and the multi-level inverter. Okay, so circuit wise it's simple, but this circuit wise is complex. That is one limitation is there. Okay, we're going to look at this is a waveform. This is a square waveform. Normally you have seen about single phase inverter square wave type of the waveform. Okay, 0 plus as well as minus it will going to come. So this is about the level. Okay, 1 0 minus 1. So this is quasi square waveform. We will going to see in about that one quasi square waveform. Then this is called a multi-level inverter. See that a multi-level is there. Then when you have joined that one, you will going to start the start to draw about the sine waveform. So you will going to purely it will going to come okay neatly it will going to come the sine waveform. Okay, so you have compare with that one this type of the waveform and as well as compare with the multi-level inverter. What about that one? It's a waveform is a poor quality waveform, but this is a type of waveform is a good quality waveform, and it is a possible for that lower switching frequency as well as higher switching frequency. You will going to possible when you have go for that high switching frequency. Already I said it is compact as well as low cost. So you will going to even you will going to use for that low switching frequency. So it is efficient and then robust one. Okay, this is about the waveform wise about that we were discussed. Then unipolar, bipolar means previously I have show you. So this is about the okay, this is a bipolar type of the waveform, the square waveform. Unipolar means we were seen about this a unipolar type of the waveform. Okay, then next one we're going to look about this is a multi-level inverter waveform. Few of the sample of the multi-level inverter waveform. So this is a level they are saying about the 2 level, 3 level, and then 5 level. How do the level is nothing but a staircase, steps we'll going to. So step number one. Okay, we are standing on the one step. Okay, one, two, then three. Three is a center line, zero line. So one, two, three, like three level. Then here you have look at one, then two, then 3, then 4, then 5. So like about the levels. So normally it is the level is normally they are going to select it. So it's a single base only. Then after that multi-level is used with 3 for 3 level or 5 level odd numbers they will going to increase. Yeah. Okay, what is few more merits and then few more points we're going to discuss about the multi-level inverter. Why do we go for that multi-level inverter? It is a reactive power compensation. So you will going to use for that reactive power compensation. High power and high voltage application you can going to use. Okay, high voltage and high power level because of the control the device in stress. Okay, is much better. Okay, so you will going to control the stress is much better. Low harmonics. Okay, low switching losses, low harmonics, and high power industry application it is used. Level is inversely proportional to the harmonics. So level is you will going to increase 3 level, 5 level, 9 level, 13 level, 25 level, 25, 49. Whenever you will going to increase the level, harmonics is a decrease, inversely proportional. So harmonics is a decrease. But you will going to level is increase means the switching is the switching devices it is increase. Number of switches you will going to increase more, and you will going to get the pure sine waveform. But due to the number of switches is increase, automatically cost wise you will going to increase. And then yeah, capacitor is a series okay seriously connected on the capacitor. Yes, so capacitor is where we were discussed. Capacitor is connected near to the source side. So source side it will going to connect it to reduce the voltage stress level. Okay, it will going to reduce, and voltage in capacitor is increase when it will going to increase, harmonics content is a decrease. So like about that one, so increase the capacitance voltage, harmonics content is harmonics level is a decrease. So that is a harmonics. THD is a harmonics. It is undesirable one. So we need to target. We need to reduce as much as possible. Okay. The different. Okay. If so harmonics level when we want to reduce, then only desired value will going to obtain it. So what is our desired waveform, desired voltage, desired output voltage, power will going to will going to obtain. IEEE also they are going to 519. They are giving the standard for that less than 5% of harmonics. So it will going to reduce the first fundamental of the harmonics as well as 11th harmonics is eliminated by the symmetrical waveform you will going to select it. Okay, high switching frequency only it will going to produce okay minimum ripple and high quality output voltage and high quality output voltage and output current. Okay, two level is not suitable for high power application. Single phase inverter is not suitable for that high power applications. So if you want to use for that high power of application means okay you need to go for that high frequency in the single phase inverter. So it says it is cannot operate on that high frequency. Even you will going to increase the frequency means what I said already, switching losses also increase. So it is constraint on the rating. So that's why single phase inverter is not suitable for high power application. Then high power application you have suppose you will going to connect it in seriously and series and parallel type of the switches. When you have connected means that is also is used, it will going to come on that one. So series and parallel operation is it will going to come. Okay, so better you will go for that only one option for that multi-level inverter. So you increase that one. Okay, it will going to increase the level to number of the voltage level. It will going to decide. CD doesn't use any that one. Okay, okay, for increasing the level, not a step up transformer is used. Step up transformer. Okay, increase the voltage. Okay, output of that AC is increase purpose. Not step up of the transformer is used. So only series of the switches is connected to. They will going to achieve. Yeah, level is directly proportional to the harmonics level, harmonics content. Yeah, sorry, inversely proportional. Yeah, inversely proportional to the harmonic content. So in order to create a smooth, okay, smooth waveform, you will go for on that one. So level values it will going to increase to, you're going to get this smooth value of the waveform as well as reduce for that one. So high okay, reduce the switching stresses dV by dt. So the harmonics content it will going to reduce. So smoothness of the waveform is proportional to that voltage level. So voltage level is increase. If high voltage level, then smoothness of that sinusoidal waveform it will going to come. So increase the voltage level of the waveform. Okay, becomes a smooth. Yes, and but it is a complexity of the controller circuits. Yes, number of level is whenever you are going to increase into 49, like you will going to increase the 49. The complexity of the circuit is increase. That is a major limitation about. We discussed about multi-level inverter. So complexity is increased and the component also increase, cost is increased, and switching pulses you need to design. So these are the drawback. Yeah, and a few more point we're going to see. High power application you will going to use, and a series for the power semiconductor switches. Yes, so series of the power semiconductor switches you will going to use several lower voltage DC source. So see, input is a DC and then output is AC. So you're using lower voltage DC source only, and then output is a higher voltage as well as higher power. So how it is coming? Series of the power semiconductor switches. So seriously connected power semiconductor switches to they will going to convert. Okay, and then input is DC, so you maybe use the battery or capacitor or renewable energy sources and you will going to use as an input. Okay, input terminal. Okay, and can be used as an multiple of the DC voltage sources. However, the rating voltage of the power semiconductor switches is a depend. Okay, rating level of the power semiconductor switches depends on that one. So rating of the switches is a depend upon the rating of the DC voltage sources. So DC voltage sources based on the rating of the switches it will going to develop. There are several topologies of the multi-level inverter is available as diode clamped inverter, and then one is a flying capacitor, cascade multi-level inverter. There are the different mechanism and the switching method is used on that one. Yeah, so this is about the circuit diagram about that one. So this is about that diode clamped, or another name is called a neutral point clamped. Neutral point, what is that neutral point? The capacitor, the center point is in neutral, so it is connected to that one. Here is a see that one here is a touch about that one diode. So here is there are two switches, here also there are two switches. There are one leg is a four switches is connected. Similarly second leg, third leg, and each leg also there is a two diode is connected. From this point to this point, two diode is seriously connected, and the center of the point is connected to the neutral. Center of the point is connected to the neutral. So instead of the diode, you will going to remove the diode and connect it to the capacitor. That's all. If this capacitor is called a flying capacitor. Flying capacitor. So input source is as similar to that one capacitor is used. Okay, two capacitor is used. This capacitor it will going to help for that one. Voltage stress level is reduced. So y means this is a value of the voltage, it will going to divide into that here and divide by 2. So divide by 2, divide by 2. Okay, it is based on that one. Suppose 5 level inverter means okay, m minus 1 capacitance value. So 4 capacitor you will going to use it on the input side. So for the capacitor you are using means 1 by 4, 1 by 4, 1 by 4 level of that one. So voltage it will going to divide it. So that is about that one. Okay, here is a flying capacitor is used. So flying capacitor as it is connected to here as well as here. And coming to the cascade multi-level inverter, okay, DC source, and then here is a actually this is a one of the research they developed. So we increase the output on that one. That's why boost converter is used. You need not to draw the boost converters. So here is a DC source, and then here is a connected to that inverter, single phase inverter. See here how it is connected on the cascade. So this is a first point, and the second point of that one, it is connected to the next is a single phase inverter seriously connected, and this point is connected to the third point, and the third point to the output. So seriously connected. Yeah, this is about that diode clamped inverter, as well as another one is a capacitor is used flying capacitor method. So simulation, MATLAB simulation, they were okay connection. So this is about that one leg only. So here is a one, I mean one base only. So you need to A base only. Similarly B base, C base you need to same method you will going to connect it. 4 switches and a capacitor, flying capacitance is you need to connect it. So like you see that one. So it is like we're going to connect it under the 3 legs. Okay. The tabulation is showing for the difference between the 3 methods. Okay, diode clamped method. So midpoint mid voltage level was that defined. The mid voltage level it will going to define about the neutral point. So this is about the flexible control method. Even flying capacitance is one of the flexible control method. So well and the basic method is a cascade multi-level inverter. So it will going to use for the both single phase and three phase conversion. The capacitance flying capacitor. So capacitor is nearer to the source side means higher voltage it will going to produce. Okay, voltage booster type of the applications, and then several megawatt applications. Okay, the capacitor is a float with respect to the earth potential. So at least three voltage level are required. So you will look for that cascade method. At least three voltage levels are required. Okay, you have look at this is a diode clamped method, and then flying capacitance method or a switched capacitance method, and is a cascade multi-level inverter. The cascade multi-level inverter also further research is developed on the 3 method, like about the bidirect DC to DC converter is used here. Okay, transformerless, no transformer is used. Okay, that's why transformer multiple multiple switches use multiple, and the transformer method is used. So like about the research is going on that this multi-level inverter. Okay, here we will going to look at a diode clamp inverter. So it's a common node. Yes, this is a point is a common node they will going to use. Okay, it is a user, and then here is a less capacitance. Okay, here is using is a less capacitance, but a diode is a it will going to it is quantitically it is proportional to the level. So the diode is directly proportional to the level based, it is going to increase. Okay, and then capacitance method means flying capacitor method. So capacitor voltage is balanced. So power flow is well in control. The power flow is well in control in the circuits. So high power density, efficient, and a single source. Okay, another one is this type of the merits about the one flying capacitor method. And a cascade method means cascade is seriously connected, well known, and then well known, and familiarly we are using one. You have looked this tabulation very clearly. It is saying about that difference between the 3 methods. Okay, what about the number of the semiconductor switches is used? This is common about the formula 2 into m minus 1. So m is the number of level 5. So 5 minus 1. So 5 minus 1 means 4. So 4 multiply 2. 4 multiply 2. What is answer? 4 into 2 8. So 8 switches is used for that these 3 commonly. Okay, clamping diode per phase. So diode per phase is you will going to use what is the method? Okay, another one is okay, diode is not applicable, not applicable. So DC bus capacitor is used. So what about the DC bus capacitor formula? It is applicable, and a balanced capacitor per phase. So see that one per phase that one here is not needed, not needed, but here is needed. Flying capacitor balancing capacitor per phase is needed, and then voltage unbalancing of the voltage is its average, it's high, and it's very small. So that's why it is a familiarly we are using. And then application wise you have see that one. So motor drive type of the systems. Okay, with statcom application, this is both is commonly there, and both are also commonly switching stress is there. Okay, motor drive application, photovoltaic, fuel cell, battery system, like it is applicable. Statcom means transmission line. Okay, fax device. Okay, transmission line improve the power factor they are using for the STATCOM. Okay, so particularly you have look about the neutral point first method. What is the first method? It is a neutral point or diode clamper method. It's high power application, better harmonics reductions. So minimize the switching semiconductor losses. It will going to reduce. So each leg you have know that one there is a four switches are used. The center point of that one is space is connected. Okay, then two series connected high side switches and there's two series connected on the low side switches. The switches is divided. Okay, clamping diode or the okay, it will going to place it between the capacitor midpoint. Okay, midpoint and then 1/4. So that one is a diode is used. Okay, if I have see that one comparison of the THD value with the two level inverter, the THD level is 22 to 32% only, but a single phase or two level inverter, the THD level is 115 percentage. Similarly, switching losses is a very less 2 watt only, but you have 2 level inverter 25 watt for the switching losses. Yeah, this is about that one connection method of the diodes. Okay, diode clamping method. Flying capacitance. Yes, here is there is a capacitor. It will going to for a balance. Okay, divide the voltage. I mean voltage stress level. It will going to reduce. Okay, flying capacitor is connected. Okay, it is also high power and high voltage and low distortion and clamping the voltage across the semiconductor devices. So flying capacitor is used. This capacitor is used for that one clamping the voltage across the switching. Okay, so semiconductor devices. Okay, topology consists of what are the it is included diode available and the capacitor available and the semiconductor devices available. Okay, diode means every switches is anti-parallel diode is used. Okay, but you have see theoretically it is designed to give for that infinite level, but practically when you have go for that limitation, it gives up to the sixth level of the voltage only. So each leg is consisting of the semiconductor switches is a device, okay, which are generally in power semiconductor transistor is used. So inverter limb or leg consists of the cells and connected inward nested series method. Inward nested series method is they are going to connected on that one. Okay, single set capacitors and two power switches is used. So every switches will going to connected for that anti-parallelly diode is connected. Yeah, here is a number of the cell. So multi-level inverter can be defined on the 2n plus 1 of the voltage level. This is a formula based. It is a voltage level is defined. So capacitor is near to the load value. They have the lower voltage. Capacitor near to the source voltage automatically higher voltage. So higher voltage capacitor you will going to use on the source side, and the capacitor near to the load value you will going to use for the lower voltage. Even power module you are going to whenever you are going to develop at the time also same power module development. The number of the level is depend on that one. So 5 level or 7 level, 9 level, 49 levels. It's a depend on the number of the conducting switches. So number of the conducting switches on that each leg. So it will going to depend. So that's why. So each leg it will going to define on that one. So if you have level is increase automatically switches also increase, cost is increase. And another name of that flying capacitor is called a implicated cell inverter. Okay. And yeah, and a few more point. So if you have see that one leg, the one leg there are two switches are connected and another. Okay, and then this higher side and the lower side. So here S1 S2 S21 S11. Then you have see that one. Okay, when S1, okay, this is called S1 and S11 is okay, it is called complementary. S1 and S1 is complementary. Complementary means at the time any one is on. S1 is on means S1 is off. Similarly, S2 and S21 is complementary. 2 is on means 2 1 2 2 okay 2 1 is off. When 2 1 is on means at the time S2 is off. Okay. Then cascade multi-level inverter. That is cascade multi-level inverter means you will going to seriously connected. Okay, that's all. So seriously connected on that three is a single base inverter. We're going to see. Yeah. So three single phase inverter seriously connected. Yes, I already said about that one. So like about they will going to develop about that cascade multi-level inverter. Cascade means series connection. So that's all about the detailed about multi-level inverter. Thank you.